codewars.com has a lab called sum of digits / digital root. In this lab, we are given a value called n. That's the only argument for this function that we are going to put together. And we are asked to add up the digits of that n number until we reach to a single digit number. For example, when n is 16, 1 plus 6 is 7, so the process will be finished because the end result is a single digit number. But for big numbers such as this one here, when the digits are added up together, the output is still a 2-digit number, so we continue with that process, and the final result for that will be 2. Let's try to put it together. So basically, let's take a very big number n in here, and our challenge here is that when we introduce n as an integer, we won't be able to work on individual digits because the digits on an integer are not iterable. Let's try to work it out. So we can have this summation sign and join function, and we will put n in here. Basically, I'm trying to add up the digits and put a plus sign in between the digits, but I can't do that because n is not iterable, because n is an integer. What I have to do first is I have to change it to a string and add them on. Now I have to put another parenthesis here. There you go. So we have the digits, and in between the digits we are given this plus sign. We put this plus sign here. We could change it to a star, which will be a multiplication operation, or a slash or division operation. So in this case, we will be a summation operation. So I'll put star, but this end result here is still a string with quotes on both ends. Python has an eval function, and eval function is very useful here. We have this parsed string. It takes the string and evaluates it as an expression. So basically, if we have a eval function in the beginning, we will basically get a result, and that will be the evaluation of this string inside the parenthesis, which is digits added up together. It's very interesting and very useful in here. So if I just print it, it is n is the integer, big integer here, and this is the evaluation operation. So I can assign it to n and run the command one more time. What I'm doing here is that I'm taking the integers of the n value and put together a string with plus signs in between the characters, and it's our new n, and I have 113. So if I repeat the same comments, set of comments again, now I will have n as 5 because 113 becomes our new n value. So 1 plus 1 plus 3 is a 5 here. Okay, so this is what we are going to do in this lab. We need to define a function, which is this here. I'll copy the function's name and repeat the summation process a number of times, where while loop can be very useful here. We will be doing this while loop. Now, the first question here is, what should we put here for the while loop breaking point? So we are trying to reach to a single digit value, single digit number. In order to do that, we need to continue with the while loop as long as the n number is a double, is not a single digit number. It can be 2 digits, 3 digits, whatever. So we will continue this while loop as long as n is more than a single digit number. And how are we going to do that? The same way that we discussed a while back can be useful. We can evaluate this compiled string where we take the individual characters and put a plus sign in between them. I guess I'm right on the parentheses here. Okay, so this is the n. So I'm assigning this output to n again because it will have a continuation of this while loop with a renewed or recomputed n value. Okay. I can print n just to see the outcome, and this function should really return the n value, and this n value should be a single digit number from 1 to 9. All right, then I can call the function digital root and put n as the argument here. Yes, this is really what I wanted to see. So we now have, on this large n number, we have 4 iterations. The first iteration gives us 165, and if you add them up together, you get 12. Add them up together, you get 3. I have 2 3s here because I'm printing n and also returning n, so I'm getting the same outcome twice. So I get rid of this print comment. It's just showing me the final n value. All right, that should work for this lab. So copy the cell and paste it over here. I don't need these pieces, so the tabs are not the same with the Colab and codewars finder. All right, I think it should work now. Okay, that's good. The second lab is called Collatz. It is similar to the first one in the way we will handle the problem. Here we are given a positive integer n, and I can open up here a positive integer value n here, and we will repeat a number of processes until we reach to a case where n becomes 1. So basically, if the given number is an even number, we will get the half of it. And if it is an odd number, we will get 3 times of it and add 1. Yeah. This lab is similar to the previous one, where we would need a number of iterations, and a while loop can be useful here too. So for if the input given is a 4, which is an even number, so we get half of it, and 2 is still an even number, we get half of it, and we finish the process. So 4, after this Collatz function becomes 1. And the second example, we are given 3 here. 3 is an odd number, so we have to increase the number by 3 times n plus 1, which is a 10. And 10 is an even number, so we take half of it, 5. 5 is an odd number, so we go 3 times 5 plus 1, 16. And then even number becomes 8, even number becomes 4, 3, so 2 and 1. That's the process. All right, so to work on this problem, we can start with an n value of 3 just to put the function together, and the function's name is that one. Well, in this lab, the way we need to present the outcome is in that format. So we will record the interim values, and we will put a dash and a greater sign in between the results, and all should be in string. Okay. Well, again, we will be using a while loop. So while, and the boundary here is basically when n is greater than 1, meaning that we will continue with this while loop until we reach to an n value that is equal to unity, and we stop the process. And in order for us to do the iterations, we have two conditions, n being even or odd. So we need to put an if statement to make a distinction here. Well, the easiest or more Pythonic way, as they call it, is putting a modulus operation here, which in this case, and the remainder of this operation, n divided by 2 here, n is 3 divided by 2 is 1. So the end result here, this operation is 1, which is a number. So in here it's a Boolean, right? So if Boolean, so in Python, the Booleans format is no, not in here, but let me bring it here. Okay. Basically, if the Boolean is empty, if it's false, if it's 0, or if it's none, the Boolean function will return a false here. If it's any number besides 0, it's a true argument, right? So in this case, n, the remainder of the n divided by 2 operation gives us 1, which is a true statement. So if that is true, meaning that the end result is not 0, it is 1, we are dealing with an odd number here. And if we have an odd number, the statement is 3 times n, well, 3 times n plus 1. And what we can do is we can just print our n value here. If I'll go else here, if this Boolean check is a 0, meaning that the remainder is 0 out of this operation, then it's an even number. So even number will return a false Boolean statement. So then n will be n over 2. And we can just print n to see what results we get out of it, right? I guess I can call the function and see what results do we get. Okay, so well, so we start with n equals 3, n is greater than 1, so while we will start. So the remainder is a 1, it's an odd number, so it will be 3 times n plus 1, which is a 10. And the process will continue. And 10 is an even number, then we will get half of it, 5. 5 is an odd number, so we get 3 times 5 plus 1. And then 8, 4, 2, because they're all even numbers. That's really what we have to do. So if you pay attention to the way it is presented, basically we need to first convert these floats with decimal numbers, or with the numbers with decimals, to integers. We can convert it to integers first, and then join them. Here we have this integer format, and then we join them with a dash and greater than symbol here. And finally, we've used return command to display this large string. Well, in this code right now, these results are not saved or assigned to a variable. So instead of print, we can just have a list. So let's start with let's say my list, and let's start with an empty list. And what we can do is we can append these n values to my list. All right, and control here, and we can do it for the else statement again. And when we return our results, we can use this dash greater than sign symbol and join the elements of my list. Let's take a look. Okay, now there's an error message here. So it says sequence item 0 expect a string instance, and we have an integer. All right, so we have integers as outcome. In fact, in this way, these are still floats. So what we can do is we can first convert them to integers. And even after changing integers, we will still get an error message because we are using an operation for strings here, but we are using integers. So what we can do then, we can change them to strings. And run this function. Okay, so what do we have here? It is showing this 10, and that's not really what I want to show here, because the indentation, the tabbing is not correct here. So we have to move it to while indentation to see the full results. Okay, so we start with 3, we get 10, 5, 16, 8, 4, 2, 1 calculated. So this is our result. But if you look at the final output here, it starts with this integer, which was 3 in the beginning. So this, the way we put together is not quite complete. So we need to add the n value to this original list here. So instead of starting an empty list, we can use n3 in here, and with that we will get an error message again, because n here is introduced as an integer, but the rest of the elements on the array are string elements. So we need to change n to a string so that everything on the list is a string. Now we have the right answer. Okay, so this function, as it is here, if I copy it, copy selection, and go to the codewars.com's compiler here, I should get the right answers after I fix this. Okay. Let's give it a try. Yes, it passed the test, and okay. And if you go with the rest, we got the right answer. All right.